welcome once again to Lectures Online Maths. Now, in this video, we want to look at what we have here. We are on our Hôpital school. We are asked to determine the limit as x tends to 0 of x minus sin x all over x squared. How can we do this? It's very simple. Now, we can solve this using the Hôpital school. Now, I'm going to show you how you are going to apply this. Now, this is the solution to this problem. Now, for convenience and for clarity's sake, I will divide this by 2. Now, look at what we have. We have the limit as x tends to 0 of x minus sine x over x squared. Now, this is the full question. Now, this is what we are going to do. By direct substitution, let me say, by direct substitution, remember, the Hôpital rule can only be used when, after applying your direct substitution, the limit is indeterminate, that is undefined. That is when you can apply your Hôpital rule. So if you do by the direct substitution and you have a definite value that is not undefined, the value should be accepted. But if the value is indeterminate or the value is undefined, then you cannot proceed by using the Hôpital rule. Hope you get it. Now, this is what we are going to do. By direct substitution, we are going to have, in place of x, we are substituting what x tends to 0. We are going to have 0 minus sine 0 in place of x all over 0 squared. You get? This is the same thing as 0 minus sine 0 is 0 all over 0. And you get? 0 minus 0 is 0 all over 0. And anything divided by 0 is undefined. Hope you can see. So you can see that by direct substitution, the limit of this function is indeterminate. It's indeterminate or it is undefined. You get it? So now, when you apply by direct substitution and it's indeterminate, you are asked to differentiate the numerator and the denominator of this particular function. That's how you're going to do it. So by applying that, we are going to take the limit as x tends to 0. And then if you differentiate the numerator, if you differentiate x, you are going to have 1 minus, if you differentiate sine x, you are going to have cos x all over. If you differentiate x squared, you are going to have 2x. Hope you get it. Now we are done with the first set of differentiation. Now by substituting these values into it, we are going to have 1 minus cos x, cos 0, because x tends to 0, all over 2 times 0, which is the same thing as 1 minus cos 0 is 1, all over 2 times 0 is 0. And then 1 minus 1 is what? 0 over 0. Which means that this function, our final answer here also, is still indeterminate. Is still indeterminate or is still undefined. And when you differentiate the numerator and the denominator and you substitute the what x tends to into the function and it's still indeterminate, you're still asked to differentiate again. You keep on differentiating that function till when you substitute, you are going to have either a real number, a rational number that will not be undefined. Hope you get. So if we differentiate this again, we are going to say we differentiate 1. We are going to have the limit. If we differentiate 1, is what? 0. Because the derivative of the constant is what? 0 minus. If you differentiate cos x, we are going to have, remember, if you differentiate cos x, the y dx of cos x is equal to what? Minus sine x. If we differentiate cos x, we are going to have minus sine x. But look at this. We have minus cos x. So it's going to, since the derivative of cos x is minus sine x, is going to be what? Minus sine x. Because we have a minus, a negative sign here. It's going to be negative sine x, which will give us what? A positive sine x. Hope you get it. So now by applying this, if we differentiate minus cos x, we are going to have a positive sine x all over. If we differentiate 2x, we are going to have 2. Then now we are done with this as x tends to 0. Now we can substitute now, and if we substitute, we are going to have, this implies, if we substitute, we are going to have 0 plus, remember sine x, it will be what? Sine 0 all over what? 2. And this implies 0 plus sine 0 is what? 0 all over what? 2. So our final answer is going to be 0 over 2, which is equal to what? 0. So you can see that 0 divided by 2 is equal to 0. And remember, 0 is also a number in mathematics. You get it? 0 is a value, it's a number, although, and then we can now say that the limit of x minus sine x all over x squared as x tends to 0 is equal to 0. And this is the value that satisfies this particular function of the rules of the Hôpital. So that's the value that's going to satisfy this particular question. So if you find this video interesting, do not hesitate, make sure you like this video and share this video for greater understanding and more understanding to the audience. You know, when you share this video, audience, people that are not they are not just on this platform, will understand it far more better. You get it? So just share it and like and comment. I'll see you in my next class. Bye.